Good evening. We start with sum number 3, part 1 from exercise 7.5. Let L be the limit. Limit extends to pi root of 5 plus cos x minus 2 upon square of pi minus x. See, in standard trigonometry, the requirement is angle should tend to 0. But here angle is tending to pi. So we have to use substitution x equal to pi plus h. Now when we use substitution, we must obtain tending value of new variable. As x tends to pi, this pi gets cancelled. So h will tend to 0. Simple. It is better if we simplify this separately. What is root of 5 minus 5 plus cos x in that case? X changes to pi plus h. What is cos of 180 plus theta? Minus cos theta. So this is 5 minus cos h. Denominator, square of pi minus x, pi minus in bracket pi plus x. So minus pi minus h, rather in bracket pi plus h. So when you open the bracket, this is pi minus h bracket square, that is h square. So we get what? Limit h tends to 0, root of 5 minus cos h minus 2 upon h square. Now you know what should be done. Yes, you have to rationalize numerator. Write down. So when you rationalize numerator, you get what is a minus b into a plus b, a square minus b square. So 5 minus cos h minus 4, that is 1 minus cos h. From trigo, it is 2 sine square h by 2. So in the next step, I have written 2 square of sine h by 2. Angle must be fully repeated. Square, so here also square. So in the process, we have written denominator as h square by 4. That is, we have multiplied denominator by 4. But originally it is h square. So we have to multiply numerator also by 1 by 4. Right? So in the next step, I will use 3 results rather simultaneously. Basically, what is 2 upon 4? That is half. Limit of square is square of limit. So limit h tends to 0. Sine h by 2 upon h by 2 bracket square into limit h tends to 0, 1 upon root of 5 minus cos h plus 2. So this is nothing but, now we are in a position to take the limit. To take the limit means use standard trigo limit, and in the second case, replace every h by 0. What is cos 0? 1. So this is 1 by 2 into 1 upon 2 plus 2. So 1 upon 8. 1 upon 8 is the answer. Right now, you have to mention this as h tends to 0, h by 2 tends to 0, and limit y tends to 0, sin y upon y is nothing but 1. Right now. So final answer is 1 upon 8. In the fourth sum, there are two methods. First, I'll tell you shortcut method. See what is numerator? Cos x minus root 3 sin x, and tending value is pi by 6. Now I write this as 2 into in bracket half cos x minus root 3 by 2 sin x. This 1 by 2 is replaced by sin pi by 6, and root 3 by 2 is replaced by cos pi by 6. Sin alpha cos beta minus cos alpha sin beta is sin of alpha minus beta. So the function becomes 2 sin pi by 6 minus x. From denominator, take 6 common to get pi by 6 minus x. Now can I say value of this limit is 1? Basically this should be, I'm sorry, this should be x tends to pi by 6. I'll change that. This should be x tends to pi by 6. Can I say value of this limit is 1? Yes, I can, because you will notice that angle is in radian, angle tends to 0 as x tends to pi by 6. Angle pi by 6 minus x will tend to 0 and it is fully repeated in the denominator. So what is the final answer? 2 upon 6, that is 1 upon 3. Right now. There is a standard method also. Put x equal to pi by 6 plus h and so on. You can try that after the lecture. It is better that you mention this as x tends to pi by 6 minus x tends to 0, and limit of sin y by y as y tends to 0 is 1. Fifth is for homework. As x tends to 1, here you have to put x equal to 1 plus h. As x tends to 1, h will tend to 0. What is the answer? 2 upon pi. Now second part, first one, L be the limit x tends to pi by 6, 2 sin x minus 1 upon pi minus 6x. Put x equal to pi by 6 plus h. As x tends to pi by 6, h will tend to 0, right? So sin x becomes sin of pi by 6 plus h, right? So what is sine of alpha plus beta? Sin alpha cos beta plus cos alpha sin beta. We get this because sin 30 is half, cos 30 is root 3 by 2. Denominator on simplification is minus 6h. Right now. So if you substitute, then on simplification you get this one, limit h tends to 0, on opening the bracket cos h plus root 3 sin h minus 1 upon minus 6h. Let me explain. Actually sin h upon h standard limit is 1. So I have written minus root 3 upon 6, limit h tends to 0, sin h upon h. Now we need 1 minus cos h, and that is why this minus becomes plus. So plus 1 upon 6, limit h tends to 0, 1 minus cos h upon h. Now next step, now this is allowed because we have separated these two parts, right? So I can say taking limit in the first case, this is standard limit, its value is 1 plus 1 upon 6, limit h tends to 0. Now it is 1 minus cos h, 2 sine square h by 2, 2 sine square h by 2. Now denominator I write as h square by 4, but original denominator is h. So I have to multiply this by what? H by 4. I hope you understood this. Should I explain this again? Okay. I'll explain this part again. See, this is common sense split numerator. Now it is 1 minus cos h, 2 sine square h by 2. Sine h by 2, so h by 2. But sine square is there, so h square by 4. But original denominator is just h, not h square by 2. And therefore I will multiply by h by 4. Simplify this. 1 upon h square by 4 into h by 4 is simply h. So we have written the same function. That is very important. So in the next step, I will say this is minus root 3 upon 6, okay, plus 1 upon 6. Now constant part is what? Basically 1 upon 6 into, I will say 2 by 4. Is this correct? 2 by 4, that is half. Yes. Next part is important. Limit h tends to 0, sin h by 2 upon h by 2 square, okay, into limit h tends to 0 of h. This is nothing but minus root 3 upon 6 plus 1 upon 12 into 1 square into 0. So minus root 3 upon 6 is the final answer. Right. Okay, I'll explain this part once again. Split numerator, this is standard limit, its value is 1. 1 minus cos h is 2 sine square h by 2. Now sine square h by 2 requires h square by 4. To get the original function back, we must have h by 4. Now limit of square is square of limit. What is limit of h as h tends to 0? 0. 0 into 1 by 12 equal to 0. So the answer is minus root 3 upon 6. Second, let L be the limit. Limit extends to pi by 4. Root 2 minus cos x minus sin x upon square of 4x minus pi. Put x equal to pi by 4 plus h. As x tends to pi by 4, h will tend to 0. I will simplify this part separately. Substitute and simplify. Cos of alpha plus beta, sin of alpha plus beta. These formulae are to be used. Cos pi by 4, 1 by root 2. Sin pi by 4, 1 by root 2. If you open the bracket, you simply get, see here sine term gets cancelled. Here it is plus, here it is minus. Now 2 times cos h by root 2. What is 2? Root 2 root 2. 1 root 2 gets cancelled. So root 2 minus root 2 cos h. Take root 2 common to get in bracket 1 minus cos h. Okay. In fact, we can find denominator also separately. What is denominator here? Original denominator. It is 6x minus pi square. Okay. So 6x minus pi bracket square. So this is 6 into. Now x is to be replaced by what? Pi by 6 plus h. Okay. Minus pi bracket square. So this is pi plus 6h minus pi bracket square. Pi gets cancelled. So this is 36 h square. Yes, 36 h square. That is denominator. Right. I'm sorry. Actually, this is not the. Please cancel this. This is not the original denominator. It is not 6x minus pi square. It is 4x minus pi bracket square. So it will not be 36h square. It will be what? 16h square. Right now. So L equal to limit h tends to 0 root 2 into 1 minus cos h upon 16h square. If we have 1 minus cos, generally we multiply numerator and denominator by 1 plus cos. 1 minus cos into 1 plus cos is 1 minus cos square, that is sin square, right? Or you may say, can we replace 1 minus cos h by 2 sin square h by 2? Yes, you can. In that case, you need not write this. But many students find it difficult to adjust the denominator. So it is better that we write this. Now constant part is to be taken outside the limit. So root 2 upon 16 into limit h tends to 0, 1 upon 1 plus cos h. Limit of this is to be evaluated separately. Now what is limit of square? I will write this directly. Square of limit h tends to 0, sin h upon h bracket square. Okay. So this is now root 2 upon 16 into in 1 upon cos 0 is 1. Now this is 1 square. So root 2 upon 32 is the final answer. Right now. Fourth one. Third is for homework. Answer is 1 by 36. If you want, we can discuss this the next lecture. Let L be the limit. Limit extends to a sine root x minus sine root a upon x minus a. What is sine a minus sine b? 2 cos of a plus b by 2 into sine of a minus b by 2. See, cosine term does not require anything in the denominator, because even if you take the limit, you do not get 0 in the denominator, right? Now, what are the factors of x minus a? Root x plus root a into root x minus root a. Next step is important. See, angle must be fully repeated. See, if you say that we will replace x by a, tending value is a and not 0, then you get sine 0, which is 0. So 0 by 0 form. And that is why you have to see that angle is fully repeated. Constant can be easily adjusted. Original denominator is root x minus root a. we have written root x minus root a upon 2. So into 1 by 2. Now in the next step, I write this as limit not h, x tends to a, x tends to a. This 2 gets cancelled. So cos of root x plus root a upon 2 upon root x plus root a as it is into limit x tends to a sine of root x minus root a upon 2 upon root x minus root a upon 2. I hope you understood this. Now to take the limit means to replace every x by its limiting value, that is in the first case, and in the second case standard trigo limit is to be used. So cos of root a plus root a upon 2 upon root a plus root a into 1. Why can I write 1 for this directly? Because all the conditions are satisfied. Angle is in radian. Angle tends to 0 because as x tends to a, angle tends to root a minus root a upon 2, that is 0. And it is fully repeated in the denominator. So this is cos root a upon 2 root a. This is the final answer. Of course, you have to mention the reason. As x tends to a, angle root x minus root a upon 2, this angle tends to 0, and limit y tends to 0, sine y upon y is nothing but 1. Right on. Now this part is again important. Limits of exponential and logarithmic functions. You have to remember these as standard limits. Limit x tends to 0, a raised to x minus 1 upon x is nothing but log a. We are doing calculus, so we need not mention the base because it is e only. Now as it is log, a has to be greater than 0, not equal to 1. What are the observations here? Index tends to 0. See, this is the index, its tending value is 0 and is fully repeated in the denominator. Actually, this is the special case of result 1. Why? Because a can be any real number greater than 0, not equal to 1. Can a be e? Yes. You know that e is an irrational number. Approximate value is 2.7182818. So it is greater than 0, not equal to 1. So in that case, what will be the answer? Log e. But log e is 1, right? Now this result is again important. Limit x tends to 0, 1 plus x raised to 1 upon x equal to e. This result can be remembered easily as something is added to 1. Listen to me. Something is added to 1. Same thing tends to 0. Something is added to 1. Same thing tends to 0. And index is reciprocal of the term added to 1. So in that case, what is the answer? It is E. E is a rational number, 2 less than E less than 3, and approximate value is 2.7182818. Write down. Write down. Note, in general, first one, limit x tends to 0, a raised to mx minus 1 upon mx equal to log a. After this, write down, index tends to 0. Write down, index tends to 0 and is fully repeated in the denominator. Index tends to 0 and is fully repeated in the denominator. Similarly, second result also, write down. And then third one. Try down. Third result. Limit x tends to 0, 1 plus mx raised to 1 upon mx equal to e. M is a real number not equal to 0. Okay. Now after this, write down. Something is added to 1. Write down. Something is added to 1. I'm referring to this. Something is added to 1. Same thing tends to 0. Same thing tends to 0. Index is reciprocal of the term added to 1. Index is the reciprocal of the term added to 1. Evaluate the following. First one, let L be the limit. Limit x tends to 0, 5 raised to 3x minus 1 upon 3x. I'm sorry, original sum is limit x tends to 0, 5 raised to 3x minus 1 upon 11x. Okay. Now what is the requirement? Index must be fully repeated. Does index tend to 0? Yes, it does. So first we write what we want. But original denominator is 11x. Please don't say add 8x to 11 because we cannot split the denominator, right? So to make the, rather to obtain the original function, I'll multiply it by 3 by 11. Check this, 3 gets cancelled, 11x, yes. Now the next step is 3 by 11 being a constant, you can write it outside the limit. So this is nothing but 3 upon 11, limit x tends to 0, 5 raised to 3x minus 1 upon 3x. Now can I say value of this limit is log 5? Yes, I can, because all the conditions are satisfied, that index tends to 0 and is fully repeated in the denominator, provided you mention the reason. So first I will say that final answer is this, L equal to 3 upon 11 log 5. Okay. And strictly you have to say that as x tends to 0, 3x tends to 0, and which standard limit? Change the variable, limit say y tends to 0, a raised to y minus 1 upon y is nothing but log a. In fact, let me explain. If you know laws of indices, of course everybody knows laws of indices, but the problem is application. See, can I say that this is, let me explain, limit x tends to 0, instead of 5 raised to 3x I can say this is 5 cube raised to x minus 1 upon, I will write 1 upon 11 outside the limit being constant. Now can I say value of this limit is log of 5 cube? Yes, I can, because a, can 5 cube be a? Yes, 125 5 cube. It is constant, greater than 0, not equal to 1. Now use laws of logarithm to get 3 log 5. So this is also correct. You get the same answer, right? But why to write this in this fashion? It is easier to express angle, rather it is easier to express index. Rather we can fully repeat that index in the denominator. Okay, right. Second one, limit x tends to 0, 1 minus 3x raised to 2 upon x. Let me explain. Something is added to 1, yes. Same thing tends to 0, yes. Index must be reciprocal of that. So required index is minus 1 upon 3x. To get original index, which is 2 by x, मैंने गलती की यहाँ पे, 2 is in the numerator, not in the denominator. Oh. we must obtain original index, right? So this is required. To get original, this is to be multiplied by what? This is to be multiplied by minus uh, 3 into 2. Is this correct? Just check this. Minus 6 upon 3x minus 6 upon minus 3x. Yes, 2 upon x. Okay. See, this minus 3 gets cancelled, 2 upon x. Now, next step, as per laws of indices, this I can write as 1 minus 3x raised to minus 1 upon 3x raised to minus 6. Why? See, a raised to m raised to n is a raised to mn. So we have written the same in the required form. Now, can I directly write the value of limit as 1? No. Limit of power is power of limit. So this is limit x tends to 0, 1 minus 3x raised to minus 1 upon 3x raised to minus 6. Now I will say this is e raised to minus 6. Why the value of limit is e? Because as x tends to 0, minus 3x also tends to 0, and limit y tends to 0, 1 plus y raised to 1 upon y is nothing but e. Right now. Yes. Third one, last one, limit extends to 0, a raised to x plus b raised to x minus 2 upon x. Can we take limit in the first step? No, 0 by 0 form. A raised to 0 is 1, b raised to 0 is 1, 1 plus 1, 2 minus 2, 0 by 0. So rearrange the terms, a raised to x minus 1 plus b raised to x minus 1. We have written the same numerator in different form. Now split numerator. Actually, I have omitted one step. On splitting numerator, you have to say limit of sum is sum of limits. Okay. So this is log a plus log b, which is log ab. Now you need not mention the base. In calculus, it is customary not to mention the base if it is e. If the base of logarithm is other than e, then only we mention the base. Okay. So we'll start solving sums from exercise 7.6 in the next lecture.